So this is class 1 of our road Euclid, right? Which is road Euclidean geometry. So I'm going to talk about a few things that I think are important that you need to understand before we can get to the circle geometries of this world. So I'm going to define a few things, and I'm going to start with angles. Do you know what angles are? What an angle is? What is an angle? So an angle, I'll just make it simple here for this case, right? So an angle is a measurement between two lines, right? So if you have a line, let's say you have a line AB, right? And this line intersects with another line CB. Do you see that these two lines intersect?
Yes.
Where do they intersect?
At B.
So they're intersecting at B. So an angle, it is the measure between those two lines. So the measurement between those two lines, here is it, this position here. Can you see?
Yes.
So it is an angle between two lines that intersect, to be specific. So I need you to be familiar with this. So the way we symbolize our angles is a letter with a caret. What is a caret? It's that thing that looks like a V, like a cap on top of it. What is that angle? What is that angle? Angle what?
Angle B.
This is angle B, right?
Yes.
Because these two lines AB and CB, they intersect at B. So this is angle B that we have there. So if you want to indicate or label or code that angle B, it should be the alphabet with a caret. So if you want to talk about angle B, it will be B like this with this thing like this. It's called a caret. Are you guys following?
Yes.
So there are different ways in which you can denote angles or you can label angles. So in this case, we use that capital letter B. Are you with me?
Yes.
So another way you can label or code angles is using the names of the line segments that make up the angle. Are you guys following?
Yes.
So I'm saying that another way in which you can quote or you can reference an angle is to use the line segments that make up the angle. For example, look at angle B. Angle B is made by two line segments. What are those angles? What are those line segments? Is this one AB and BC or CB? Are you guys following?
Yes.
So we can also name this angle B according to those line segments. So in that case, you can also say your angle B is the same as A, B, C, and you put your caret there, which is your A, B, C. So it's named according to those line segments that form your angle B. Are you guys following?
Yes.
Which is also the same as, you can say it's C, B, A. But the caret must be there so that it shows you where the angle is sitting. So that cap is your caret. So that cap must always be there to show you which angle you are talking about. Are you guys with me?
Yes.
No problem. So if I'm giving you an angle like this is angle B. You must be able to see which lines are forming angle B. Do you see that this is angle B?
Yes.
So angle B is between AB and BC. That's how you see it. Are you following?
Yes.
So angle B is between AB and BC. And this angle B is between what?
CB
Between CB
and PA.
and PA. So if you're given an angle like this, you should be able to trace it where it's sitting at, because you can have many lines intersecting at B. So you might not know which one they're referring to. The way to, like the method that you should be using to identify the angle of interest should know that If I talk about angle B here, is angle B is formed by AB and BC, or your angle B is formed by CB and BA. That's how to look at this thing. Are you guys happy?
Yes.
So, your angle, I said an angle is the measurement between two lines that intersect. It's the angle between the two lines that intersect, right? So, your angles are measured in what units? Your angles are measured in degrees. So, the units of measurements of angle isn't degrees. So, angles are measured in degrees. Are you following? And degrees is that small circle like that. I'm sure you've seen it before. Which means if you're writing an angle 25, it should have that degrees. And if you're writing an angle, it should have that cap over there, that caret. Because if you don't have it, how will someone know it is an angle? Because that is a short method for angle to refer to an angle. Are you guys still following? No problem. Then now, we have a few types of angles, right?
Yes.
So what kind of angles do you know?
Acute angle.
There's acute angle. So we have an acute angle. Do you know what an acute angle is?
It's an angle less than 90.
It's an angle less than 90. But you need to be specific. It's an angle between 0 and 90 degrees. Which is it's less than 90, but greater than 0. Are you following? Are you happy? An acute angle is an angle that is less than 90 degrees, but greater than 0. So it's an angle that is between 0 and 90 degrees. So, which means, if we're talking about an acute angle, A, right? You will know that if A is an acute angle, it's less than 90, greater than 0 degrees. Or your angle A is an element of what? 0 to 90 degrees. That's an acute angle. So when someone speaks about an acute angle, they speak about an angle that have this size. Are you guys following?
Yes.
Another angle?
Obtuse.
Obtuse angle. So, we can have an obtuse angle. What is an obtuse angle? Does anyone know?
Is there an angle that is is there an angle that is greater than 90 but less than 180?
Yes. An obtuse angle. Let's say obtuse angle. So because it's A, I use A there, right?
Yes.
So it's O, I'm going to use O. So your obtuse angle O is more than 90 degrees. Are you with me?
Yes.
But less than 180 degrees. That's the definition of an obtuse angle. Or you can say your obtuse angle is an element of 90 degrees to 180 degrees. So, any angle that falls on this interval is an obtuse angle. I'm not sure if you remember, when you were doing analytical geometry, if you were calculating an angle of inclination for a negative gradient, it was always an obtuse angle. It was always more than 90 degrees, but less than 180 degrees. But pay attention to that next time when you are doing analytical geometry. Are you guys following?
Yes.
Okay, do you know other angles?
Reflex.
Reflex. Okay? Something called reflex angle. What is a reflex angle? Okay?
Is there an angle that is greater than 180
Okay.
but less than 270?
Less than 360.
360.
So, your reflex angle is an angle that is measured to be less than 360 degrees. Should have a caret there, right?
Yes.
But greater than
180.
180 degrees. That's a reflex angle. Are you following?
Yes.
And then what else? So let me have stars next to these angles. This is angle 1, angle 2. There is angle 3 over there.
And there's a right angle.
There's a right angle. We're saying there's a right Angle. What is a right angle?
An angle that is equal to 90.
Yes, an angle that is measured to be exactly 90 degrees. That is your right angle. So it's an angle equal to 90 degrees. That's a right angle. Okay, what else?
The other one. Is there a revolution?
Revolution. Right? So, what is a revolution? I'll say a revolution is I'll just try to make it as simple as possible. I'll say I'll define it as angle that is equal to 360 degrees. Right?
Yes.
So, revolution. Can you guys see?
Yes, yes.
Okay. Your revolution is an angle equal to 360 degrees. What else? Straight angle.
Yes.
Does anyone know what a straight angle is?
Yes.
Straight angle. Straight angle. What is a straight angle? Straight angle.
An angle that is equal to 180.
Yes, angle on a straight line. So a straight angle is equal to
180.
180 degrees. Zero angle. Zero angle.
Do you have a zero angle?
Yes, what if there is no angle between two lines?
There's no angle.
Yes, it's zero. So, zero angle is this angle here, Z, which is equal to
Zero.
0 degrees. Are you guys happy?
Yes.
This is all I can think of at this very moment. There's nothing much that I can think about. Any questions?
No questions.
Okay. So then I'll move from this end because I just wanted to remind you a bit and speak about triangles. So we have different types of triangles, right?
Yes.
Types of triangles. I think everyone should know. Give me one.
Right angle triangle.
There's a right angle triangle. Right triangle. Or right angle triangle. So, how would you define this triangle? How do you identify it?
It's a triangle that has that 180 degrees. It has 90.
Yes. So, on a right triangle, one of the angles is 90 degrees. Are you guys following?
Yes.
If you have a right triangle, one of the angles is what?
It's
90 degrees, which means it's those triangles that looks like this. And there's a box there which is on 90 degrees, whatever the case may be.
Yes.
I'm sure you've seen them before.
Yes.
And there's a theorem that is applied on these triangles. What is it called?
Pythagoras.
Pythagoras theorem is applied on these triangles. Are you guys following?
Yes.
Another triangle?
Isosceles.
Isosceles. I'm not sure if the spelling is correct. So, this triangle, how can we define this triangle? Tell me about it. What do you know about an isosceles triangle?
Opposite sides are equal.
Okay, it's a triangle that has two equal sides.
Yes.
Right? So, if you have an isosceles, you'll have two equal sides. What else? And two equal angles. Which angles? The angles that are equal will be angles that are opposite these sides.
Yes.
So for example, this side, you can see this side here.
Yes.
It's opposite this angle here.
Yes.
And this one is equal to this angle. So the angles that are opposite equal sides are equal. Are you following?
Yes.
Sorry?
You said?
I'm saying, if you have an isosceles triangle, it has two equal sides and two equal angles. If these are two equal sides, the angles opposite those sides are also equal. Is everyone happy?
Yes.
No problem. What else?
Scalene.
Scalene. Okay, scalene. What is a scalene triangle?
A triangle that all sides are not equal.
All sides are not equal, and also
All angles are not
and all angles are not equal as well.
Yes.
So we have a scalene. So looks like this. You can see that all these sides are not equal. Same thing with the angles. The angles are not equal as well. Are we happy so far?
Yes.
What else do we have?
Equilateral.
Equilateral triangle. Equilateral triangle. So we have equilateral triangle. So how do we define this one?
All sides are equal.
All sides are equal, and the angles?
And all angles are equal.
All angles are equal as well. What are they equal to?
180.
Each one of them. What is it?
It's 60.
Each one of them is 60. So an equilateral triangle, all sides are equal, right?
Yes.
Like this. So this equal to this and this equal to this. So this side will be equal to this side, will be equal to this side, and all of them will be 60s. Are we guys happy
Yes.
so far? No problem. So I want to talk a bit more about these triangles, right? This will connect more with your analytical geometry. It's part that I didn't cover when I was doing analytical geometry, because I was hoping to cover them when I'm doing this course. The classification of these triangles. You can have a right angle triangle, isosceles, and a scalene, or whatever. So triangles can also be classified according to their angles. For example, look at this one. It's called based on its angle. If you're looking at this, can you see? It's named by its angle. There's no property that relates to sides or anything, except that it has 90 degrees. So it's named. The first triangle is named based on the angle. Are you guys with me?
Yes.
So in that case, I want to name some triangles based according to their angles that they have. For example, we can have an acute triangle. An acute triangle. What do you think an acute triangle is?
It's a triangle that is an angle that is less than 90 but greater.
All the angles are acute angles. So if you're talking about an acute triangle, all the angles are acute, which is that or less than 90 degrees. For example, the equilateral. Can you see that your equilateral is an acute angle? Is an acute triangle. Because all of them, they are all less than 90 degrees. Because it's 60, it's 60, it's 60. Are you guys with me?
Yes.
Are you guys following?
Yes.
So I'm going to link this with your analytical geometry a bit so that you guys can flow even better on that topic. So this is an acute triangle because all the angles are less than 60 degrees. That's what an acute triangle is. And most of the time, their shape are something similar to this. All those angles will be small like this. Are you with me?
Yes.
And you know that this area is called half the base times
Perpendicular height.
half the base times the perpendicular height. Are you following?
Yes.
And then again, let me write that right triangle again. Right triangle. So same thing as well. Like I said, it has 90 degrees this one. Like this. If you want the area of it, it's half your base times your height. And you can see that height is a perpendicular height as well. Are you guys with me? So the area of this triangle will be half your base times the perpendicular height, which is that. Is everyone happy?
Yes.
No problem. Also, we can also have an obtuse triangle, which is one of the angles in the triangle is more than 90 degrees. So, for example, let's look at this. Obtuse triangle. So, let's say, I'm sure you've seen triangles like this before. This looks more like 90. Let me try to draw it. I'm trying to draw a triangle. I'm not sure if this really works. Does this look like a triangle? Okay, so let me draw it down here. So look at it. So you can see that is not an acute angle over there. Or is it?
No.
No, it's not. It's not. Also, let me just draw it in a much nicer way. I think I found a way. So let's do it like this. Does it look better now? Because you can see that this angle here is more than 90 degrees, this one, and less than 180. Because for it to be 180, it should be a straight line. So this is an obtuse triangle. If you want to calculate the area of an obtuse triangle, it's half your base, right? Here's your base. Here's it. Sitting with it. Times the perpendicular height. What is the perpendicular height? It's the height of the triangle, which means how tall is it from the base? Not the length from your base to that, but how high is it above the base? So, which means, in order to see the height, you must imagine that this continues straight on. Is this height over here? This height over here. Are you happy?
Yes.
Is everyone happy?
Yes.
So your area equal to half base times the perpendicular height. This will be your height if you have an obtuse triangle. Are you guys following?
Yes.
Are you guys following?
Yes.
That's how to do this thing. I didn't have to do this part, but because I remember I didn't do this when we were doing analytical geometry. So you must be familiar with this. So if you're calculating a triangle, it can be this, it can be this, it can be that. I don't think there are others. It will fall on these in each one of these. Are we happy so far?
Yes.
Okay, no problem. Then I'm going to clean this, and then we're going to go to lines, to talk about lines. Okay, so now we're going to talk about lines now. I like lines a bit. I'm going to come back to triangles when we're done about lines, because I'll start with this and go to that. I don't have a very nice way of presenting this, but I'll try to make it more cohesive so that you guys are following. So let's suppose that you have two lines intersecting. Can you see these lines?
Yes.
And they intersect, they form A, B, C, and angle D. Can you see those angles
Yes. Yes.
that are there?
Yes.
Can you see those angles?
Yes.
So let's suppose that I add those angles. First angle is angle A, plus angle B, plus angle C, plus angle D. What is the sum of these angles?
360.
It's 360 degrees. Why? We define a revolution to be 360 degrees. So it's up to you where you start. I started by adding angle A. Do you see where angle A starts? Angle starts here and goes there. That's A. B starts here. Can you see?
Yes.
And C, D. Do you see that you go around a circle. That's a revolution. That's why they add up to 360. So you have added all the angles. You have added all the angles that are around this point. Because you see on the northern side you have A. On the, what is it? This is the eastern side. On the western side you have B. You have C. You have D on the east. That should be the western side. Are you guys following?
Yes.
So you have A, you have B, you have C, you have D. So you've added all the angles that are around that point of yours where the intersection is occurring. So if you add all of them, they add up to 110 or to 360 degrees. Are you guys following?
Yes.
So anytime when you're adding angles that completely surround a point, they will add up to 360. And when you do that, what will be your reason for that?
Angles around the point.
It will be angles. This should be angles, right? Angles
Around
around a point. I'm not sure if this is clear. Is this clear?
Yes.
So if you add angles that surround a point, they will always add up to 360 degrees. Because that will be a revolution. You'll be going around a point, a full cycle around a point. Are you guys happy?
Yes.
Okay. Then now, it makes sense if you think about it. I said that it's one of those things. There are theorems. Theorems, you state them and prove them, right? There are definitions, which is where you explain the concept of what you're trying to do. For example, this is a definition. So we define a revolution to be 360 degrees. It is defined to be, like you define other things as well. So it is a definition that angles around a point is 360 degrees, right? And there are things called axioms. Axiom is a statement as well, like a theorem. But the difference is that an axiom, you don't prove it. It's more like some self-evident. You can see it. It's more like obvious. For example, what is the angle around this point? Sum of angles around this point is 360. What if I was to slash that angle in half? I would have 180. I don't think I need to prove that. It is straightforward. So it is an axiom. So a straight line, you get it from an axiom. It is an axiom because you can't really prove that. Maybe you can, but it's something that is intuitive. You can even see or you can visualize it. Because I have this circle here, maybe. Let me try to draw a circle here. Let's say this is your cylinder here. So angles around this point is 360 degrees. So if you slash it in half, this is what happens. So you should have 180 on top and 180 at the bottom. Are you guys still with me?
Yes.
Okay. So, in simple terms, is that if I add now a straight line is half the angles. A straight line will have half the angles around a point. Does that make sense?
Yes.
I'm saying a straight line contain half the angles around the point. Because you can see here, you have these two lines meeting, right?
Yes.
So another straight line will have another half and another half.
Yes.
Same thing with this one. There's another half this side, other half on the other side. So it should be clear that if I add any two pairs on a straight line, they should give me what?
Two pairs.
If any two pairs of adjacent angles there, they should give me what?
180.
So if I add any two neighboring angles there, they should give me what? 180. Adjacent angles are angles that are next to each other. Are you with me?
Yes.
Are angles next to each other, sharing the side and the vertex. Are you guys following?
Yes.
Okay. So, for example, is B adjacent to C?
Yes.
Yes.
Okay, so Abuza, one by one. Is C adjacent to D?
Yes.
Is A adjacent to B?
Yes.
Is C adjacent to B?
Yes.
Is C adjacent to A?
No.
Is D adjacent to B?
No.
Which is good. Because, look, the ones that are adjacent are next to each other. And they what? They share a side and a vertex. So this one is adjacent to this one. This one is adjacent to this one. This one is adjacent to this one. That one. Are you guys happy?
Yes.
So if I were to say to you, angle A plus angle D, what should I get?
180.
Should be 180 degrees. Why do you say that?
Adjacent angle on a straight line.
It's angles. Let's just say angles on a straight line. These are angles on a straight line. Okay, this is the first one. So, if I were to say angle B plus angle C, what do I get to see?
180.
So, it's B and C. You can see that they're on line as well.
Yes.
So, it's going to be 180 degrees. Why is that?
Angles on a straight
These are angles on a
line.
on a straight line. So the angles on a straight line are supplementary. Right? But we don't have to say that because we've already said that there. Are you guys following? So if I add C and D, what is C plus D?
180.
C plus D equal to 180 degrees. Same reason, angles on a straight line. One more. What are we missing?
D and A.
A plus D. Angle A.
Oh, we already have it.
What are we missing?
We have AB.
A
Yes, B.
plus B. They give me what?
180.
Why? Angles on
line.
a straight line. Are we happy with this so far?
Yes.
Yes.
Are you guys with me?
Yes.
Okay. So we're happy with adjacent angles. Are angles that are next to each other, sharing a side and a vertex. Are you guys following?
Yes.
Okay. So now I'm going to talk about vertical opposite angles. Right?
Yes.
We'll talk about vertically opposite angles. Do you guys know what these angles are?
Yes.
What are vertical opposite angles?
I can give an example.
Example, what is it?
For an example, A
Okay, what
and
example?
C.
Example. Now say angle A
and angle C
and
are vertical opposite angles.
angle C are vertical opposite angles. Do we have more there?
Yes.
What else?
B and D.
B and D. B and D. Okay. So if you have two lines intersecting, right? You have two lines intersecting, right? The angles that are opposite each other. You can see, right? You know what opposite, which is the angle facing each other.
Yes.
So if you have two intersecting lines, the angles that are opposite each other are called vertically opposite angles. A and B and D, right, are not vertical. You can see that they have a horizontal orientation, but they're still called vertically opposite angles nonetheless.
Can you repeat?
I'm saying vertical means this orientation, but you can see that A and C, they do have that orientation.
Yes.
But you can see B and D are horizontal to some degree.
Yes.
So they are still called vertical opposite angles. We won't say horizontal opposite angles. They are just called vertical opposite angles just for simplicity.
Okay.
So even though they are horizontal or they are slanted, still they are still called the same name, if you may. Are you here, busy? Okay. So I'm going to go with a theorem. Let me say theorem VET. So on this theorem, I'm calling it theorem VET because I'm going to talk about vertical opposite angles. So on theorem VET, I'll state that if you have two intersecting lines, vertical opposite angles are equal. Which means this angle is equal to this one, and this angle is equal to that line. Are you guys with me?
Yes.
So, you don't have to know this. You don't have to know the proofs. I just want you to know the theorem and be able to use it. That's all I want. Are you guys following?
Yes.
So, if two lines intersect, right? Then vertically opposite angles are equal. Are you guys following?
Yes.
So, I'm saying to you, if you have two lines that intersect, the vertical opposite angles will be equal. So, in this case, let's say we have these two lines. This is line number 1. This is line number 2. And they intersect. So, you have your vertical, your angles A, B, C, D. So, if I'm saying vertical opposite angles are equal, that is a claim. It's something that I'm claiming, right? That if I'm having these two lines intersecting, then the vertical opposite angles will be equal. What you need to understand about most of the statements in maths is that first part of the statement of the theorems, most theorems that you will do, you'll find that the first theorem is giving you conditions, what must happen first. And then the last part will tell you what will be the result of that. Look at this situation here. I'm saying now, if you have two lines intersecting, so I'm telling you, make two lines intersect. Then this is what you will get afterwards. So most of the statements that you'll be proving, they have the first part that is giving you the conditions first. The last part is telling you what will be the result of that. Small line. Do you see that they are saying that if you put your salt, if you pour your salt in a cup of hot water, then the mixture will be sour. Do you see the first part is a condition telling you what you should be doing or what needs to be done, and then you are told the end result at the end that the mixture will be salty or it will be sour, whatever the case may be. So most of the statements that we'll be doing are like that. So it's important to be able to understand what is the first part, what are the conditions, because the conditions that they are telling you is what they are giving you. So you will be expected to work with what you are given to prove what you're not given, or to prove the claim. So in this case, if two lines intersect, so these two lines intersect, they're saying make two lines intersect. If you do that, they're saying the vertical opposite angles will be equal. Are you following?
Yes.
Okay. So in this case, I've made two lines intersect, line 1 and line 2. So now what I have to do is to show that the vertically opposite angles will be
Equal.
so my claim, what I need to prove is the claim, right? Claim is what I need to prove. They said, what is the claim? Say. What is the claim saying?
If the two lines intersect.
That is the condition.
Then the vertical opposite
Yes,
angles
are equal. So the claim is always what you're trying to prove. It's what you're trying to prove. It's what you're stating. I'm saying this. I want this. This will happen. That is your claim. Are you guys following?
Yes.
So in this case, the first part before then is the conditions, what you are given. After that is what you should be proving. So you are told that two lines intersect and make them intersect. Then vertical opposite angles are equal. So now you need to prove the part after the then. Are you guys with me?
Yes.
Okay. So which means the claim is the part that is what I'm claiming will happen. It's what I'm saying is going to happen. What are they going to saying is going to happen? They're saying the vertical opposite angles are going to be equal. So that's what we need to be proving. So which means we need to prove that A is equal to C
Yes.
and
B.
OB is equal to
D.
D. There's no need for me to do these theorems. But these theorems are simple theorems that will prepare you for the real ones that you guys are expected to do. Because it's important to be able to identify the conditions, which is what you are asked to do, which means make the lines intersect and know what you are expected to prove. Do you guys understand?
Yes.
Are you following?
Yes.
Are you happy? Okay. So let's try to prove this now. So this was our claim, which means when I say this is a claim, it's what I'm going to prove this. So let's go to our proof. So if I can add A and B, if I can say A plus B, what do I get?
8.
It's called 180 degrees. Why is that?
Yes.
These are angles on a
Straight line.
straight line. Are you guys happy?
Yes.
I added what? A and B. Are you guys with me?
Yes.
So now, I'm going to add B and C. So I added A and B, I'm going to add B and C. You could have said A and B and add A and D. It's up to you. So, what is, I said A and B is 180 degrees, right?
Yes.
What is B plus C?
108.
B, angle B plus angle C is equal to 180 degrees. Why?
Angles on a straight line.
These are angles on a
Straight line.
straight line. How is this 180 compared to this one?
They're equal.
Yeah, they're the same, they're equal. So 180 degrees is equal to 180 degrees. Which means your A plus B is equal to your
B plus C.
B plus C. Because they are both equal to 180.
Yes.
Are you guys following?
Yes.
This you knew from the lines. Right?
Yes.
And then you saw that you got 180. The sum of those all those angles that are there, they gave you 180, right?
Yes.
180 is the same as another 180. So if the right hand side of these two equations are equal, so are the left hand sides. So which means your A
Plus B.
plus B
Is equal to
is equal to what?
B plus C.
B plus C. So look, this and this that go away. Therefore, your angle A is equal to your angle C. Isn't that our claim? This is our claim. We're done here. We're going to move to the second claim. Are you guys following?
Yes.
Fine. So in the second claim, it's up to you the order you use. Because look, because my goal at first was to show that A is equal to C. Right?
Yes.
I made sure that B appears twice so that B can go away. Because you can see there's B on top, there's B at the bottom. So now, what do I want to show? I want to show that this is equal to this. I have two options. I can make A appear twice or make C appear twice. Are you with me?
Yes.
I can say B plus A is equal to A plus D. The A's will appear twice. I can say B plus C is equal to C plus D. So the B's and D will just appear once, and whatever direction I choose will appear twice. So let's do that. Do you want the top or the bottom one? Okay. So B plus C, B, angle B plus angle C is equal to 180 degrees. Why? Angles on a straight line. I know it's boring to write this thing all over the time, all over again, right? But you have to write it because the person who's marking you need to know that you know this. Right?
Yes.
Okay. So we said B plus C. What is C plus D?
180.
C plus D is equal to 180 degrees, right? Why?
Same.
Angles on a
Straight line.
straight line. Because C and D, they're on this straight line. You can see. Fine. Isn't 180 equal to 180?
It is.
So which is the right hand side is called the right hand side of the first equation is equal to the right hand side of the second equation, which means so are the left hand sides. Because which is the sum of this is 180, sum of this is 180, which is these two things are equal. Which means your B, angle B plus your angle C. It's called your angle C plus your angle D. So this and that go away. Therefore, your angle B is equal to your angle D, which is this part. So, what I need you to take away from this, if you have two angles, two lines intersecting, vertically opposite angles are equal. Are you with me?
Yes.
So, which means, if I'm giving you something like this, E, F, G, H, these are two lines, line 1 and line 2. Which angles are equal?
E
E
equal to G.
equal to G. Why?
Vertical opposite.
This is the reason. Vert opposite angles. These are vertically opposite angles. That is the reason for usage. You say vert opposite angles, vertically opposite angles. Which other angles are equal, Siwa?
It's F
F, angle F,
and H.
angle H. Why?
These are the vertical opposite.
Vert op angles. That's all I needed you to take away from this. Are we happy?
Yes.
Are you sure?
Yes.
Any questions for me?
No questions.
Okay, so what I'm going to do, I'm going to clean the board and then we're going to move on a bit. Okay, so I'm going to talk about lines, right? In this case, I'm going to talk about parallel lines. Do you guys know what parallel lines are?
Yes.
What are parallel lines?
Are the lines that have the same orientation?
So, parallel lines. Parallel lines, right? I'll just simply define them. Are lines that have the same orientation. They have the same orientation, which means they have the same shape. If one is horizontal, one parallel to this will also be horizontal. If one is vertical, one parallel to this will also be vertical. Right? And also, in simple terms, for geometrical reasons, if the two lines are parallel, they say they never meet. So let's say lines that have the same orientation and
Never met.
never meet. Are you guys happy?
Yes.
Yes.
So if lines are parallel, I'm going to write two lines. This line, let's say, and another line here like this. If lines are parallel, they are indicated by arrows like this. They are indicated by arrows like this. Then these two lines are parallel. So if you see a diagram with these two kind of arrows in the same direction, it means that these lines are parallel. They have the same orientation. Are you with me?
Yes.
Okay. Then, now, I'm going to define a transversal. Right? I'm going to define a what? Transversal. So, I'm going to make a transversal be specific to parallel lines in this case. I can give you a definition for a general transversal, right? A transversal is a line that cuts two or more lines. Are you following?
Yes.
A transversal is a line that cuts two or more lines. Are you with me?
Yes.
But now I want to be specific and cater for parallel lines, because the most, like, we are mostly on your Euclid level, on a level Euclidean geometry. you're expected to understand transversals on parallel lines. So I'm going to define a transversal on a parallel line. A transversal on a parallel line is a line that cuts two or more parallel lines. So this transversal that I'm defining for you guys is specifically for what? For parallel lines. Are you with me? Yes. So a transversal is a line that cuts two or more lines. Let me just make it general.
Two or more lines.
Yes.
Not parallel lines.
They don't have to be parallel. So transversal is a line, right, that intersect two or more lines. So these lines need not to be parallel. Are you with me? Mm-hmm. But the ones that you will be working with mostly, or the ones that we are more concerned about, are the transversals that cuts parallel lines. Are you with me? Yes. So, if you have this line and this line, and these two lines are cut by this line, by the third line, that line is called a what? It's called a transversal. So, when I say transversal, I needed to think about a third line cutting two or more lines. Is it clear?
Yes. Oh, yes.
So when I say transversal, I needed to think about the third line cutting two or more other lines. That's all I needed to think about. No problem. So now, but we're going to focus mostly on parallel lines. So let me go to our parallel lines. And we're going to define a few things or a few angles there. Then I'm going to stop for the day afterwards. So, let's suppose that you have two parallel lines, which is the two lines that have the same orientation. So, you can think of these lines as copy and paste of each other. Right? So I'm telling you that these two lines are what? Are parallel. Just think of them as copy and paste of each other. It's more or less the same line, but you copied it here and pasted it there. Because they have the same orientation. Can you see both of these lines are horizontal?
Yes.
Are you with me?
Yes.
Okay. Let's say these two lines. Let's say this is line AB. This one is CD. Let's say these two lines are intersected by a third line called EF. Can you see EF?
Yes.
What color is EF?
Right.
Okay. The line EF, what is it called that intersect two or more other lines?
Transversal.
It's called a transversal. Are you with me?
Yes.
No problem. So, here is what I need you to think about. Right? This line and this line, they have the exact same orientation. They have the exact same shape. Right? And both of them are both intersected by it's more like we have a duplicates of these lines. Right? Because these are duplicates of each other. But other is just on a different position than the other. They're not aligned. Like one on top of the other. Are you with me?
Yes.
Okay. So think of these lines that have exactly the same orientation. So these two lines that have the exact same orientation are both intersected by a third line. Would you think that third line will intersect them in different manners, or they will intersect them in the same way?
In the same way.
Because if both of these are parallel, which they have the same orientation, they are more or less copy and paste of each other. Right?
Yes.
They are intersected by another line. That line will intersect them exactly the same way. I'm not sure if you hear what I'm trying to say.
Yes.
So if you have two parallel lines and you have a transversal, the transversal will intersect both of them in the exact same way. Because this line have a gradient, whatever gradient, the gradient of EF is the same. Are you with me?
Yes.
The gradient of EF is you know the gradient, because a line have the same one gradient, uniform gradient, right? Because the gradient is the same throughout. So the gradient of EF is uniform, it's the same, right? The gradient of CD is also uniform, it's the same as well. And it's the same as that of AB. So if you intersect EF or EF and CD, and your EF also intersect AB, the angle at which, the angle between the two lines, the angle between the transversal and your parallel lines, it should be exactly the same. Which means this green angle here, it should be exactly the same as that one. Because it's like the red line is intersecting the blue lines in the exact same way. Are you following me?
Yes, sir.
Are you with me?
Yes.
I don't want to repeat this thing again. But let me try for the last time. I'm going to say, if you have two parallel lines, and those two parallel lines are intersected by a transversal, the transversal is going to intersect them exactly the same. Because it's more like you're intersecting the same line twice. Are you guys with me?
Yes.
Are you guys following?
Yes.
This line EF is more like intersecting the same line twice. I'm not saying CD and AB are the same, but they have the exact same orientation. So the angle between them should be exactly the same as well. Are you okay? Okay, no problem. So it's not only going to be these ones. This one, this one is the angle. Okay, this angle here is on the left hand side. Oh, sorry, it's on the right hand side of the red line and below the blue line. Are you with me?
Yes.
Can you see this one as well? It's on the left hand side. It's on the left hand side of the red line and below the blue line.
Yes.
Okay. So this one here will be the same as that. Are you with me?
Yes.
This one here will be same as this one here. Are you guys following?
Yes.
And try to find another ink, and this one here will be the same as that. So what you see here, you are seeing angles sitting in the similar position, being equal. These angles, the green angles, are sitting in the same position relative to the transversal in the lines, in the parallel lines. So this angle and this angle are sitting in similar positions. Can you see?
Yes.
Because they are both on the left hand side, on the right hand side of the red line and below the blue line. And these ones are on the right hand side of the red line and above the blue line. So those angles that are sitting in similar positions between the transversal and the lines are called corresponding angles. So this angle and that angle, they are called corresponding angles. This one and that one, they are called corresponding angles. Because they're sitting in the same position in relation to the transversal and the line. Are you guys following?
Yes. Yes.
And I said this angle and this angle will be equal. This angle and this angle will be equal. This one. So if you have a transversal intersecting two parallel lines, the corresponding angle should be equal. This is not a theorem. This is an axiom. It's something that you can see. Because it's like you're intersecting the same line twice. So you should intersect them in the exact same way. Are you guys following?
Yes.
No problem. So, if I were to clean this off, let me clean this. And say, this is A, B, C, D, E, F, G, and H. Are you guys following?
Yes.
Okay. So, I want us to point out the corresponding angles here. That's what I want us to do. Corresponding angles, in simple terms, are the angles that are sitting in similar position between the lines and the transversal. Are you guys with me?
Yes.
Okay. So, tell me your corresponding angles.
A and E.
Yeah?
It's A and E.
Angle A is equal to
Angle E.
angle E. Why? They are corresponding angles. And your corresponding angles are only equal if the lines are parallel. Are you with me?
Yes.
Your corresponding angles, A and E, will be equal if the lines are what? Are parallel. Because if they are parallel, which means you have the same line twice. Are you with me?
Yes.
So you have the same line twice. So you will intersect it the same way by EF. So your corresponding angle should be the same. So if you're saying angle A is called angle E, it's fine, you should tell us that they are corresponding angles. But you should also state that the lines that are intersected by your transversal are also parallel. Because the only time these two will be equal is if the only time these two are equal is if your transversal intersects two lines that are parallel, or that have or in a more informal way intersecting the same line twice. Because if you're intersecting the same line twice, you're intersecting the same way. Are you guys with me?
Yes.
Okay. So in this case, we're saying angle A is equal to angle E. Why? Because they are corresponding angles on parallel lines. So what you need to say is, okay, my angle A is equal to angle E, they are corresponding angles. Where? What you need now to say is to tell them that you're saying they are equal corresponding angles because your AB is equal to your what? Your CD is parallel to CD. So you need to be specific about that and say, okay, my AB is parallel to CD. So you need to be very specific about this. You need to be specific around this. Are you guys with me?
Yes.
Is it difficult?
No.
So you need to tell them that my angle A is called my angle E because they are corresponding angles on parallel lines. So which means I say angle A is called angle E, these are corresponding angles because your AB is parallel to CD. So do you guys see Z? Do you see any other corresponding angles?
Angle D.
Angle D,
Supposed to angle H.
angle H. Why?
Corresponding angle.
Corresponding angles.
AB parallel.
Your AB is parallel to
CD.
CD. See what do you see more?
Yes.
It's
Angle C
angle C,
and angle F.
angle F. Why?
Corresponding angles.
These are corresponding angles, right?
Yes.
On parallel lines because your AB is parallel to CD. And so on. I don't have to say all of them. Your angle G
G. Supposed to be.
is called angle B. Why? These are corresponding angles on parallel lines because your AB is parallel to CD. So if you're telling me that you see corresponding angles, you should also tell me with the parallel lines so that I can go and see them myself as well. Are you guys with me?
Yes.
No problem. I'm going to close this and down and now and write a statement for it. Let me close with a statement for this part. So I'm going to say now, this is an axiom, right? So what? It's an axiom, which means I don't have to prove this. This is straightforward. Are you with me?
Yes.
If two parallel lines are intersected by what? By a transversal. Then, you understand?
Corresponding angle.
Then, corresponding angles,
Are equal.
angles are
Equal.
equal. Are you with me?
Yes.
Are you following?
Yes.
Look at the statement. If two lines, two parallel lines, are intersected by a transversal, do you see this is a condition?
Yes.
I'm saying intersect two parallel lines by transversal. If you do that, then the corresponding angles will be equal. So the first part is what you are asked or you are given. It's a given, the first part. The second part is a claim. It's more like if you drink,
Alcohol.
you will be drunk. Which means the condition for you to be drunk, drink alcohol first. So alcohol, there is alcohol available. Drink and see what will happen. So if you see two parallel lines and you see transversal cutting them, no, your alternate angles are equal. Your corresponding angles are equal. Are you with me?
Yes.
Okay. So I'm going to say this is an axiom, right? Let's say, let me name this axiom so that I can be able to name other things. Let's say this is a what? Corresponding angle axiom. Are you with me?
Yes.
It's not a theorem. It's a corresponding angle axiom. So, I'm going to state the converse of this. Do you know what a converse is?
Yes.
What is a converse?
It's
It's a different direction now, going backwards. Because here, we said, if we're given two parallel lines, and those two parallel lines are intersected by a transversal, right? Then the corresponding angles are equal. So if you're checking the converse is going the other way. So we're saying now, if we see two lines that are intersected by a transversal, you said I didn't say they're parallel. I just said you just see two lines that are intersected by what? By a transversal. Such that the corresponding angles are equal. Then those lines are parallel. Let me just draw this. I'll do it the same way I did that. So, you have this line here, and this other line here. Did I say they're parallel?
no.
I didn't say they're parallel. Let's say they're intersected by this. Can you see?
Yes.
And the angle between the transversal and the line is K. Can you see?
Yes.
And the angle between this line, transversal and the line, is also K. These angles are angles that are sitting in the same position. Right?
Yes.
What is the name given to angles that are sitting in the same position?
Corresponding angle.
They are corresponding angles. Are you following?
Yes, sir.
The angles that are sitting in the same position are called corresponding angles. Right?
Yes.
But on parallel lines, they are equal. That's why you need to specify that A and E are corresponding angles. Duh, we can all see. But the reason you're saying they're equal is because the lines are parallel. Are you with me?
Yes.
Look at this now. You have these two lines. Say E, F, G, H. And you have a transversal AB. Are you guys with me?
Yes.
I'm telling you that you have two lines. I didn't say anything about parallelness. Line EF and GH. They are both intersected by transversal AB. Such that your corresponding angles are what? Are equal. Can you see?
Yes.
If this angle is equal to that angle, which means the transversal is intersecting these lines in the exact same way. Did you hear that, Sil?
Yes.
What did I just say?
You said if two lines. Okay. Okay. You said if two lines are intersected by transversal.
Such that the corresponding angles are equal. What that tells you is that the only way these two angles are equal is if this one is exactly the same way as that. Uyavumazi?
Yes.
Uyandivasiwe?
Yes.
You have a transversal AB intersecting both of these lines. Your alternate and your corresponding angles are equal. If your corresponding angles are equal, what that tells you is that this one have the exact same orientation as that, because there's no way, if this one was like this, there's no way this angle is going to be equal to that one. Are you with me, Zee?
Yes.
If this angle was like this, you see this, the angle will be smaller.
Yes.
So the only way these correspondings are equal is if these two lines have the same orientation. And if they have the same orientation, what does it mean? It means those lines are parallel. This is also an axiom. It's straightforward. Don't need to prove this. The only way your corresponding angles are equal is if the two lines have the same orientation. Which means this line AB is hitting both of these lines in the exact same way. Which means that both lines are sitting in the exact same way. Any questions for me?
No question.
No question.
So, in simple terms, I'm saying if you have two lines, because the converse of this, if you have two lines that are intersected by the transversal, such that or so that the corresponding angles are equal, then the two lines are parallel. And I wanted to look at the statement after writing it. I'm saying if two lines, you see it's a given, if two lines are intersected by the transversal such that the corresponding angles are equal. Look, it's what I've drawn. You have two lines intersected by the transversal, corresponding angles are equal. So it's what you are given. From that, it is safe to say that the two lines are what? Are parallel. If two lines, see, I said if two parallel lines. So now I'm just talking about lines because I'm going backwards. If two lines are intersected, intersected by a transversal, such that the corresponding angles
Are equal.
are equal. Then the two lines are parallel. That's all I need you to know today. So, this thing is not a theorem. It's a corresponding angle axiom converse. It's another direction of that, opposite direction. So it's a converse of that. Corresponding angle axiom converse. You don't have to know this axiom, what are the names of these things. All I need you to know is that if you have two parallel lines and those two parallel lines are intersected by a transversal, then the corresponding angles are equal. The corresponding angles are angles that are sitting in similar position in between the transversal and the lines. Right? And then I said that if you have two lines and those two lines are intersected by a transversal so that the corresponding angles are equal, then those two lines are parallel. They don't have to tell you that the two lines are parallel. The corresponding angles will do that for you. And here,
Yes.
any questions?
No question.
I'm done here. And I hope this does make sense to you, as it does to me at least. So, when I want to pick up on corresponding angles and all other sort of angles, so that we can start going with business. We're done for the day.